Hello, welcome back to my channel. In this video, I'm going to talk about the modulus and argument of complex numbers in polar form. If this is your first time here, and if you want to upgrade your math skills, make sure you subscribe my channel by hitting the subscribe button below so that you won't miss any video later, because the following video I'm going to talk about the power and root of complex numbers using the Polaris theorem. If you find that this video is useful, please share to your friends, to your students, or to anybody who need this. So let's start the lesson right now. In this video, I'm going to talk about complex numbers in polar form. A complex numbers in Cartesian form z equals x plus yi can be represented by using an Argand diagram. Now when we look at this Argand diagram, the distance from the complex number to the origin we label as r. And from this coordinate, we know that this is x and this is y. And theta is the angle between the real axis and r. From here, cos theta is equal to x over r. Then x is equal to r cos theta. And also, sin theta is equal to y over r. So y is equal to r sin theta. So, for z equals x plus yi, now I replace the x with r cos theta and y with r sin theta. When I rearrange the expression, then I get z equals r cos theta plus I sin theta. So this r cos theta plus I sin theta for the complex number, that is what we call it as the polar form of the complex number, where r is the modulus of the complex number z, that is the distance from the z to the origin, and theta is the angle between real axis and the r, that is we call it as argument of z. The value of r is greater than 0 and the value of theta is greater than negative pi and less than or equal to positive pi. If we want to change complex numbers from Cartesian form into polar form, there are two values we need to find. One is the modulus, another one is the argument. To find the modulus, we can use the formula square root of x squared plus y squared. To find the argument, it depends on the position of the complex number. If the complex number is in the first quadrant, then argument is arctangent y over x. If it is in the second quadrant, then the argument is pi minus arctangent y over x. If third quadrant, then the argument is negative pi minus arctangent y over x, or arctangent y over x minus pi. Then if it is in fourth quadrant, then the argument is negative arctangent y over x. Now I'm going to discuss in detail about modulus and argument. Now let's try to find the complex number in polar form for z equals 3 plus 2i. So first I'm going to find the modulus by using this formula. Since x is 3, y is 2, so when I sub into the formula, then the modulus is square root of 13. As for the argument, since this complex number is in the first quadrant, then the argument is arctangent y over x. So, since y is 2, x is 3, so when I press calculator, I'll get 0.588 radian. So the polar form is this one. Next, for the complex number z equals -2 plus I, to find the modulus, since x is -2, y is 1, so when I sub into the formula, I get the modulus is square root of 5. Now as for the argument, since x is negative, y is 1, so means the complex number is in the second quadrant. First, I'm going to find the arctangent of positive y divided by positive x to find the basic angle of the second quadrant. Then the argument of the complex number in second quadrant is this one. So to find this angle, then I have to use pi minus the basic angle arctangent positive y divided by positive x. So therefore, the argument for this complex number is pi minus arctangent, y is 1, x is -2, so I need to use the modulus to get the positive value of x. So when I press calculator, this is 0.4636. Then pi minus 0.4636, it is equal to 2.678 radian. So therefore, the polar form is this one. Then for z equals -4 minus 4i, for modulus, x is -4, y is -4. So when I sub into the formula, I find that the modulus is square root of 32. But I find that square root of 32, it is not the simplest form of the surd. So means I can still separate 32 into 16 times 2. Then square root of 16 is equal to 4. So means the modulus in the simplest form of surd is 4 square root of 2. Then as for the argument, since x is negative, y is negative, means this complex number is in the third quadrant. First, I'm going to find the value of arctangent of positive value y over positive value x to find the basic angle of the third quadrant. Then the argument of the complex number in third quadrant, it is not this angle, because when we use pi plus this angle, it is greater than pi. Since we know that the argument is less than pi, so in order to get the argument which is less than pi, so we will take this angle as the argument. So in order to get this angle, so this angle is equal to pi minus the basic angle. Then the whole thing is equal to negative. So it is negative pi minus arctangent y over x. Therefore, the argument for this complex number is negative pi minus arctangent, y is -4, x is -4. So when I press calculator, it is pi over 4. So negative pi plus pi over 4, it is equal to -3 over 4 pi radian. So therefore, the polar form is this one. Then next, for the complex number z equals 2 minus 4i, since x is 2, y is -4, so to find the modulus, when I sub into the formula, I get square root of 20. But square root of 20, it is not the simplest form, because I can still separate 20 into 4 times 5. Then square root of 4, it is equal to 2. So modulus is 2 square root of 5. Then as for argument, since x is positive, y is negative, means the complex number is in the fourth quadrant. So for the complex number in fourth quadrant, the argument is this angle. This is a negative value, so the argument is negative arctangent y over x. So therefore, the argument for this complex number is negative arctangent, y is negative 4, x is 2. So when I press calculator, it is negative 1.107 radian. So the polar form is this one. Next, z is equal to 3i. When z is equal to 3i, so means the value of x is equal to 0. So to find the modulus, we substitute into the formula x equal to 0, y equals to 3. Then we find that the modulus is 3. Now as for the argument, since the position of this complex number is at the positive imaginary axis, so from the diagram, it is very clear that the argument for this complex number is 90 degrees, that is pi over 2. So the argument for this complex number is pi over 2 radians. So therefore, the polar form for this complex number is this one. Next, for z equals negative 3i. So when z equals negative 3i means x is equal to 0, y is negative 3. Now to find the modulus, when we sub into the formula, now the modulus is 3. Then as for the argument, from the diagram, we know that the position of this complex number is at the negative imaginary axis. So from the diagram, we can see that the argument is negative 90 degrees, that is negative pi over 2. So therefore, the polar form for this complex number is this one. Now z is equal to 3. When z is equal to 3, so actually the complex number is z equals 3 plus 0i. X is 3, y is equal to 0. So when we want to find the modulus, we sub into the formula. Now the modulus is 3. Then as for the argument, from the diagram, the position of this complex number is at the positive real axis. So means the argument is 0. So therefore, the polar form of this complex number is this one. Then when z is equal to negative 3, so means x is negative 3, y is 0. Now to find the modulus, when we sub the value of x and y, we find that the modulus is 3. Then as for the argument, from the diagram, the position of this complex number is at the negative real axis. So when the complex number is at the negative real axis, means the argument is pi. So therefore, the argument for this complex number is pi radians. And so the polar form for this complex number is this one. Now we go to multiplication and division of complex numbers in polar form. If we are given two complex numbers z1 and z2 in polar form, then we can multiply z1 and z2 where the product is also in polar form. Now the modulus for this z1, z2 is equal to the modulus of the first complex number z1 multiplying the modulus of the second complex number z2. Then for argument for this z1, z2, it is equal to the argument of the first complex number plus the argument of the second complex number z2. And when we divide these two complex numbers, z1 divided by z2, the quotient is also in polar form, where the modulus of this z1 over z2 is equal to modulus of the first complex number divided by the modulus of the second complex number. Then as for the argument for this z1 over z2, it is equal to argument of the first complex number minus the argument of the second complex number. Before we can do multiplication and division of complex numbers in polar form, first we must make sure that the polar form is in the correct polar form. The correct polar form is cos plus I sine. So when we look at here, this is the correct polar form. But when we look at this one, this is not the correct polar form because this one is not positive but negative. So we must change this one to positive. So when we change this negative to positive, the angle becomes negative. This is because we are using this formula. So when we look at here, cos negative pi over 3 is equal to cos pi over 3. Sine negative pi over 3, it is equal to negative sine pi over 3. So now after this, we find that this is the correct polar form. So now we can do the multiplication. So to do the multiplication, so we multiply the modulus 5 times 3. Then as for the argument, we use the argument 3 pi over 4 plus negative pi over 3. So after simplify, so this is the answer. Now let's look at this example. Before we start, we must make sure that the polar form is correct. So when we look at this one, it is correct. But when we look at here, it is not correct. So because this is sine, this is cos. So this is not correct. So to change sine to cos, cos to sine, now we are going to use the complementary angle. That is cos theta is equal to sine pi over 2 minus theta. Sine theta, it is equal to cos pi over 2 minus theta. So now we want to change sine to cos. So it is becomes cos pi over 2 minus 3 pi over 4. And cos change to sine become sine pi over 2 minus 3 pi over 4. Then when we simplify, we will get negative pi over 4. Now, these are in the correct polar form. Now we can do the division of the complex number in polar form. First, the modulus 5 divided by 3. Then for the argument, 5 pi over 6 minus negative becomes positive pi over 4. When we simplify, we get 13 pi over 12. Now when we look at this argument, 13 pi over 12, it is more than pi. So we know that argument is less than pi. So therefore, if the argument is greater than pi, then we have to minus 2 pi to make sure that the argument is in this interval. If the argument is less than pi, then we have to plus 2 pi. So here, 13 pi over 12, it is greater than pi. So we need to minus 2 pi. So when minus 2 pi, we will get negative 11 pi over 12. So this is the answer. Now let's look at this example. Before we start, we need to double check the polar form. Here we find that this polar form is not correct because this is negative and this is negative. Now we need to change to positive. So to change the negative to positive, now we factorize the negative out. So here the polar form is correct. But now for this negative cannot combine with the modulus because we know that the modulus must be greater than 0. Now to solve this problem, let's look at this diagram, if a complex number z is reflected through the origin, then we will get the negative z. So the modulus for negative z is same as z, but for the argument of negative z is equal to theta plus or minus pi. So same thing, if we want to change negative z to positive z, the argument of the negative z must be plus or minus pi to get the argument of z. So here we want to change negative to positive, so the argument must be pi over 3 plus or minus pi. So here I choose plus pi. So when we simplify, we get 4 pi over 3. Now the polar form is correct. So now we can do the division. So when we do division, the modulus 5 over 3, then for argument 3 pi over 4 minus 4 pi over 3, we get negative 7 pi over 12. So this is the answer. Now I'm going to give you an assignment. By using the method that you have learned in example 10a, 10b, and 10c, express each of the following in the correct polar form. You can log into Teacher Ailin Math Group by using the link given here to check your answer. Hope you can get the answer. Now in this example, I'm going to use the properties of modulus and argument to solve problem. Let's say it is given that a complex number z given in polar form. Now based on this complex number, express each of the following in polar form. Now I want to find the complex number negative 11z in polar form. To find a complex number in polar form, first I need to calculate the modulus. So based on these properties of the modulus, so modulus of negative 11z, it is equal to modulus of negative 11 times modulus z. Then modulus of a negative number, it is positive 11 times modulus z. So modulus z, I can get it from here, that is square root of 7. So modulus of negative 11z is 11 square root of 7. Now as for argument, based on the properties of the argument here, so for the argument of negative 11z, it is equal to argument negative 11 plus argument z. So now for this negative 11, if we want to find the argument, so we try to write this negative 11 in complex number, that is negative 11 plus 0i. So when we look at the Argand diagram of this complex number, x is negative 11, y is 0, this is the complex number. So when the complex number is at the negative real axis, then the argument is equal to pi. So argument for negative 11 is pi. Then argument of z, we can get it from here, it is 4 pi over 5. Then when we plus, we will get 9 pi over 5. But 9 pi over 5 is greater than pi, means we know that we need to minus 2 pi. So after minus 2 pi, we get negative pi over 5. Therefore, the polar form for this complex number is this one. Next, we want to find the polar form for the complex number z times conjugate z. So first we need to find the modulus So based on the properties of modulus, modulus of z times conjugate z, it is equal to modulus z times modulus conjugate z. And for the conjugate z, conjugate means we do reflection of the complex number by using real axis. So means modulus is still the same as the z. So modulus for conjugate z is same as modulus z. So modulus z we can get from here, that is square root of 7. So means finally we will get 7. Now as for the argument, now based on the properties of argument, so we know that argument for z times conjugate z, it is equal to argument z plus argument of conjugate z. So for conjugate z, after reflection we find that the argument is negative of the z. So means argument for conjugate z is negative of argument z. So argument z minus argument z, it is equal to 0. So therefore the polar form for this complex number is this one. Next, we want to find the polar form of this complex number. So we start from the modulus. So based on the properties of modulus, we know that modulus of square root of 7 over z square, it is equal to modulus of square root of 7 divided by modulus of this one, z square means z times z. So same thing, modulus z times z, it is equal to modulus z times modulus z. And modulus of a number, it is same as the number. So modulus z we can get from here. So finally we will get the answer, that is square root of 7 over 7. Then we go to argument. So first we know that z square, it is equal to z times z. Then by using the properties of argument, so we know that argument square root of 7 over z times z, it is argument square root of 7 minus z times z, it is argument z plus argument z. So as for this one, square root of 7, when we write in the complex form, that is square root of 7 plus 0i. X is square root of 7, y is 0. So when we look at this diagram, this square root of 7, it is at the real axis, positive real axis. So positive real axis, the argument is equal to 0. So and argument z plus argument z, it is 2 argument z. So we minus 2 argument z, we get it from here. So 2 times 4 pi, then we will get 8 pi. 0 minus 8 pi over 5 is equal to negative 8 pi over 5. But negative 8 pi over 5 is less than negative pi. So means I'm going to plus 2 pi, so that the argument is in the interval where argument is greater than negative pi and less than positive pi. So after plus 2 pi, so it is equal to 2 pi over 5. So therefore, the polar form is this one. Next, we want to find the polar form of this complex number. So from the properties of modulus, we know that the modulus is modulus square root of 7 times modulus of I times modulus of conjugate of z. So for modulus of a number, then we get the number back. Then as for I, first we try to write the I in Cartesian complex number form. So we get 0 plus I. So x is 0, y is 1. And also we know that the modulus of conjugate z is same as the modulus of z. Now for this one, when we look at the diagram, x is 0, y is 1, that is at the imaginary axis. So imaginary axis y is 1 means modulus is equal to 1. So as for modulus of z, we can get it from here. So finally the modulus is 7. As for argument, we know that based on the properties of the argument, so the argument is equal to argument square root of 7 plus argument I plus argument conjugate z. So for square root of 7 and I, when we write in the Cartesian complex number form, so x is square root of 7, y is 0. For this one, x is 0, y is 1. So for argument square root of 7, based on this diagram, we find that this complex number is at the real axis, so the argument is 0. As for this one, based on this diagram, the argument is pi over 2. So as for the argument of conjugate, so we know that it is negative argument of z. So argument of z we can get from here, that is 4 pi over 5. So when we simplify, we get negative 3 pi over 10. So therefore the polar form is this one. Now I have summarized the properties of modulus and argument in a table so that it is easy for you to do reference. So that's all for now. Do you understand what you learned today? If you have any question, let me know in Teacher Ailin Math Group. In the group, you can find some useful mathematics ebooks and some questions with solutions. If you find that this video is useful, hit the like button. Don't forget to subscribe. Thank you so much for watching. I hope you can keep on learning and keep on watching my videos, and I hope to see you soon. Bye.